Alright, everybody. Today we'll be covering section 2.1, linear equations in one variable. And once again, I preface this with the fact that I am at home and not at my office where it is nice and quiet. So you may hear strange noises in the background. I apologize in advance. If you have any questions or have trouble understanding me at any point, please email me. I'll be happy to reply to those. One other thing I was going to mention. Oh well, it'll come to me. Alright, so linear equations in one variable. Solve linear equations, solve absolute value equations, solve linear equations for one variable, and solve application problems, i.e. word problems, which all students love. So we have some definitions. We say an expression is a combination of variables and numbers using any of the standard operations. An equation is a statement that two expressions are equal. For example, we only use the word equation if we have an equal sign in it. And here we have x plus 1 equals 3, makes it an equation. Any number that gives a true statement when substituted in for a variable in the equation is called a solution to the equation. For example, 2 is a solution of the equation x plus 1 equals 3. In other words, if we plug 2 in for x, we get 3 back out. Finding the values for x that make an equation true is called the solution, also called the solving the equation. When we list all the solutions of an equation in braces, we call it the solution set. So in other words, these curly braces mean you want to include all the things, and usually to denote finite number of things, or at least some list or roster format you can list them in forever, like all the even or all the odd numbers or something like that. We use these curly braces. Often in your homework in Hawks, they have the curly braces. When they want you to list all the equations, they'll give it to you in a box where you can turn. They already have the curly braces around it. Some equations are not like that. Most of those have been taken out of Hawks. If you encounter a situation where you're not sure you can use curly braces or not, if they don't let you put them in, then you can't use them in your answer. You cannot. Two equations that have exactly the same solutions are called equivalent equations. Alright, conditional equations, and is an equation where some values of the variables, is an equation where some values of the variables are solutions and some are not. For example, we have x plus 1 equals 3. In other words, not every number will solve this, so it's conditional. An identity is an equation that's always true. For example, we have x plus 1 equals x plus 1 is an identity for every number, every solution. This can be written as all real numbers or double bar r. And interval notation we'll see in a little while. It can be written as negative infinity to positive infinity as well. Double R bar is a choice in your solution set on your keypad in Hawks, so you don't have to write it like this. Sometimes they have a radio button that you can click to say all real numbers. And so moving on, a contradiction is an equation that is always false. For example, x plus 1 equals x. There's no number we can add 1 to and get itself back. So there's no number that satisfies this equation. A solution set is the empty set, and that's usually denoted with your 0 with a slash through it. Sometimes you'll see it curiously with an empty set of braces with nothing inside of it. And once again, there's a difference between the empty set and 0. 0 is a number. No solution means there isn't anything that solves it. For example, if I asked you for the number of people that lived on the moon, currently, is 0. But if I asked you for the list of the names of the people who live on the moon, that would just be an empty set. There's nothing to go in there. Linear equations in one variable. All equations that can be written in the form of ax plus b equals c, where a, b, and c are real numbers. A is not equal to 0, because then it would just be b equals c. Are called linear equations. Also, we'll later discover that that's because our variable is to the first power. These equations are solved for x by isolating the variable. So how to solve a linear equation? To simplify the linear equation, we by removing the grouping symbols and combining like terms. So first thing we do here when we have this equation is that we'd say, okay, we're going to distribute this 3 and get rid of all our parentheses. So here we have 3x minus 6, because 3 times 2 is 6, minus 1 equals x plus 1. Add terms to both sides or subtract them that would cause one side to have only one variable. So here we're going to combine these like terms. So we get the 7. And then we're going to add terms to both sides to get all our x's on one side, all our constants on the other. So, or variables, in this case it's x. We're going to subtract x from both sides, we get 2x. And then we add 7 to both sides, so we get 8 over here. So we get 2x equals 8. And then once we do that, we multiply or divide sides by the coefficient of the variable. So we have 2x equals 8, so that divide both sides by 2. 8 over 2 is 4, x equals 4. Note, if all the variables cancel, you have a contradiction, no solution, or an identity. Every number is a solution. For example, if you had something like x plus 5 equals x plus 4, and you cancel your x's, and you say, well, 5 never equals 4, so that's empty set. Or if you had something like x plus 5 equals, and I'm just making these examples up. When you cancel x's, 5 is always equal to 5, so it doesn't matter what x was. All real numbers are your solution. Alright, so in these examples, when we go through them, I'll be going through the majority of the steps that we're taking one at a time. When you're working yourselves, as long as you're showing enough work to where you can explain to yourself at a later date and to the teacher, then that's all the work you need to show. I know some students will show every step that we had in our previous example here, where they'll show, dividing by 2 as a separate step and so forth and so on. Later on, I'll be combining my steps. I don't skip steps for brevity and just to save space. But if you ever have a question on something where I may have combined steps and you don't see how to get there, please let me know. All right, so this first equation is pretty straightforward. I'm just going to subtract 40 from both sides. When I do that, I'll get 10x. I don't have any grouping symbols to get rid of. Equals, and that's going to give me 30. So all I have to do is divide both sides by 10. And I get x equals 3. And that's your answer. You could also say x is the solution set. If it said x and then it has curly braces, you put 3 in it. If it wants it as a solution set. Usually they'll already have curly braces around what they want you to plug in. Here we're going to get rid of this grouping symbol first, multiply through by -5. So we're going to get negative 5x, and then negative times negative makes this positive, so that's going to be 15 plus 15 equals 10. I'm going to subtract 15 from both sides. So that gives me negative 5x equals, and that's going to be negative 5. I'm going to divide both sides by negative 5. And so now my negative 5's cancel here. I get x equals 1. So like I said, you can write this out as many steps as you need to make sure it makes sense to you. But I try to show as many steps, and I want you to show as many steps as it is to follow along in the equation. And the Hawks, they have, you can go through practice mode where they'll take you step by step, and you may have to enter every step. And some of the steps are steps that you combine, but they want you to enter them separately, so watch out for that. So if you get stuck on the practice mode and be like, I don't know where I should go from here, you don't understand, make sure you read the instructions very carefully. They could be asking for steps that you'd normally combine together as one step. Here he says we want to solve this equation right here for x. So first thing I'm going to do is distribute my 2's. I have my 2 here on this side, so I get 2x minus 2 plus 3 equals x. Then I'm going to distribute this negative 3 minus 3x, and that's going to be negative 3 times 1, which is negative 3. So now that I have that, I'm going to combine all my like terms, just so we can make sure we see there's a lot going on. So I'm going to combine these like terms, and I'm going to get 2x plus 1 equals negative 2x minus 3. Now here's where I have a lot of students that see I have a 2x here and negative 2x here, so they just cancel. Don't do that. You cancel, you get the wrong answer. Remember, if you want to cancel something on opposite sides of the equal sign, they have to have the same value and the same sign in front of it. They both have to be positive if you want to cancel on both sides. But here I'm just going to add to both sides. I'll add 2x plus 2x. So that's going to give me 4x. Oops, a little close. Plus 1 equals negative 3. I'm going to subtract 1 from both sides, and I get 4x equals negative 4. So that gives me x. And this is a step where I would have students assume that when it's a straight up, we're dividing by 4 here and there's 4 here, I would assume that students could go from this step to this step mentally, combine those steps. But if you need to write a separate step where you divide both terms by 4, you can do that. So once again, combining for brevity, saving spaces, that's saving paper space, that's fine. I would consider this a normal step for students to take, but you know, if this was a horrible fraction or I need to reduce this fraction, that was going to take a little bit of work, I would expect to see the actual division carried out. Equations with fractions. If a fraction, or say, if an equation has fractions with only numbers in the denominator, it can be converted to an equation without fractions. To do this, we multiply every term on both sides by the least common denominator, or LCD, I always say the least common denominator, of every denominator in the equation. This will result in an equation with no fractions. Sorry. Alright, so to make life easier, we could add these fractions together and find least common multiples or denominators and add the fractions together. But since we have this equal sign, it's easier just to clear out all the fractions. So just to go over least common denominators real quick, the easiest way to find a least common denominator of anything is, let's say we had the numbers. So this is a separate example, so least common denominator. So let's say we had like 24, 18, and 15. So I want to find the least common multiple, actually this is least common multiple of these numbers. If I was going to find the least common multiple of these numbers, I would just have their prime factor. So here we'd have the prime factor of 24, and that's going to be 24 is what? 4 times 6. Right? And you can rewrite that as 2 times 2 times 2 times 3, which is going to be, oh, I didn't leave myself enough room, as usual. That's going to be, let me write it down here. 24 is equal to 2 to the third times 3, so that's 8 times 3. 18 is equal to 2 times 9, which is 2 times 3 squared, and 15 is equal to 3 times 5. Now looking at this, what you go through for this is you find the highest power of each prime factor. So the highest power of 2, the highest power of 3, and the highest power of 5. Now it doesn't need to come one from every single, like one of these numbers could be the least common multiple, and I grab all my numbers from there. You don't have to pick one from each one. If this was 3 squared, I could have picked the 3 squared from there. It just happened that they all happen to be in separate terms, mainly because I didn't want my least common multiple to be that big. So the least common multiple in this case would be, I need at least 2 to the third, 3 squared, and 5. And you can multiply that all out, and that would be 8 times 45, because that's going to be 8. That's going to be 9 times 5 is 45. And 8 times 45, whatever that is, that'll be your least common multiple. Can't think of it off the top of my head. It'd be 40, I want to say it's 360, is that right? I think that's right. 360, I think. So here I would do the same thing. I'd go off the side and I'd find the least common denominator, and I'd say 5, 2, and 6. Let me write that up here. Least common multiple of the denominators, same thing. And so 5 would be just 5, and 2 would just be 2, and 6 would be 2 times 3. So I'd have to go around and have to find the highest power of 2 or 5. 2, and 3. Once again, you don't need to select them. I could select the 2 from here as well. Just happen to be like that. So the least common denominator is going to be 5 times 2 times 3, which is going to be 6 times 5, which is going to be 30. Can you all see that up there? And so basically what I'm going to do is I'm going to multiply both sides by 30 to get rid of my denominator. So I'm going to have 30x over 5 minus 30 over 2 equals 30x over 6. If we did everything correctly, we should get these to factor. So this would be a step that I would assume students would be able to do, but I'm going to show, well, it'd be students could leave this out, but I'm going to show it for now. So I'm going to say 30 is 5 times 6 times x in the numerator here. This is 5. My 5s are going to cancel. This is going to be 2 times 15. And this is going to be 2 in the denominator equals 6 times 5 times x all over 6. I'm just doing this so you can see the denominator cancel. Now if you wanted to go straight to the step where you said 6x minus 15 equals 5x, that would be acceptable. This intermediate step may not be needed for some students. If you need to show it, especially if there's a lot of division going on, maybe it's not necessarily clear what's going on, I would definitely leave it. So here I'm going to subtract 5x from both sides. And that's going to give me, let me rewrite that up here. So that's going to give me x minus 15 equals 0, or just move that to the other side, x equals 15. Alright. Once again, you can always check to make sure that this is the correct answer. You could go check, and you could have 15 over 5 minus 1/2 equals 15 over 6. Yep. So you could do this, and you could say, you do the math and following, you figure out, multiply everything by 30, you're going to get the same thing. It's going to check out. You can punch in your calculator too, check it out as well. We have one where they have fractions in it, and I see a lot of students do this, and it just makes their life so much harder, and I'm not sure exactly where they learned it, but they'll multiply all the fractions out. And the easiest thing to do before you multiply numbers by fractions, if they're already been factored out, just multiply by the denominator if you have an equal sign. So our least common denominator here, this could be thought of being over as 1, would just be least common denominator. The least common multiple of the denominators would just be 4 and 1, so that would be 4 overall. So I'd multiply this side by 4 and this side by 4, and that would give me 5x plus 6. Now you can write this 4 over 4 if you want to out here, do that, and then be minus 3 times 4. I'm not going to bother to say this is 12 because I'm just going to cancel out the 4's anyway, and that's going to equal negative 3 times 4, which is going to be negative 12. So it's going to be 5x plus 6 minus 3 equals negative 12. So I'm going to combine my like terms on this side. That'll be these terms right here. And then I'm going to have 5x plus 3 equals negative 12. And then I'm going to subtract 3 from both sides. And that's going to give me 5x equals negative 15. And once again, if you just wrote this as 5, or x equals 5, negative 5, I'd be fine. But once again, some of you all might want to divide both sides by 5. You may not be, and then I did it wrong after I said don't, you can skip that step. That's why you don't skip it sometimes. It'd be negative 3. I had 5 stuck in my head. Alright, and you can get fractions back out. You can get horrible fractions back out. It's fine. It's just for these examples, we often use whole numbers, so they're easier to check, easier for students to follow along. But in Hawks, you could definitely get fractions back out, or fractions that need to reduce, like we got here. Sometimes they don't reduce to integers or whole numbers. Alright, so absolute values. For any real number a, the absolute value is, if a is positive or 0, then the absolute value of a is equal to a. If a is negative, then the absolute value of a is equal to negative a. And an equation like the absolute value of x is equal to 5 has two solutions, x equals 5 and x equals negative 5. So what happens here, there may not be always two solutions to the absolute value of x being negative 5 has no solutions because absolute value can't have a negative number output. The absolute value of x is equal to 0 only has one solution where x equals 0. So basically, the absolute value is how I like the students to think about it, is the distance from 0. So 5, when you say the absolute value of a number is 5, you can be 5 units away from 0 in either direction. So 5 units here and 5 units there just gives you negative 5 is 5 units away from 0, and positive 5 is 5 units away from 0. So that's how you get this right here. Now, distance can never be negative. That doesn't make any sense. Kind of like negative area or negative volume. It's constant, physical constant, something you have to have hold. The only time it can have one answer in our number line situation, the absolute value being 0, and 0 is 0 distance away from 0. So distance is the easiest way to think about it. Solving absolute value equations for when c is greater than 0, if the absolute value of if the absolute value of x is equal to c, then x equals c, or x equals negative c. The absolute value of an expression, in this case ax plus b, equals c, then the ax plus b equals c, or ax plus b equals negative c. I know some of y'all were probably taught, and I've seen it in past schools, is where you change the sign on the left-hand side, and I prefer not to do that due to the fact that you have two signs you have to change instead of just one over here on the constant. But either ways, you can make both these negative and keep this positive, but I prefer to keep this as the same as it was inside the absolute value, equal to the negative of what it was on the outside. Standard form, the absolute value expression is isolated one side of the equation. You may need to manipulate the absolute value equation to get it into standard form before you can solve it. So we want to put it in standard form, because if we can put it in standard form, then we can apply this rule. If it's not in standard form like this, with absolute value on the left-hand side by itself, c on the right-hand side, or constant, then you need to manipulate it so it's like that. So here we have the following, where we have the absolute value of x minus 4 equals 12. In other words, I have x minus 4 equals 12, or x minus 4 equals negative 12. Since it's in standard form, we can immediately go to this step. And then so I'm going to add 4 to both sides. I get x equals 16, or I'm going to add 4 to both sides here. I'm going to get x equals negative 8. So here, if we were to solve for x, we'd say x equals, and once again, Hawks will probably already have the curly braces for you there, and it doesn't matter what order you put these numbers in when you're just putting them in as a solution set. Sometimes they'll have separate boxes. They'll say x equals, have a box, and then they'll have x equals and then another box. So they can list it. And sometimes you won't fill in all these boxes. They'll give you multiple boxes for answers sometimes, and you won't use all the boxes. So be aware of that. If they give you one box and you have multiple answers, chances are they want it in set notation, or just to list everything and the numbers separated by a comma. Please read the instructions, go through the practice mode if you're not familiar with Hawks. So here we have an interesting equation. We have a negative on the inside, but that's not really what we're concerned with. It's the negative on the outside that's a problem, because even since it's in standard form, basically you're saying the distance is negative. And that never happens. So that's no solution. So this can't happen. No solution. The distance can't be negative. Distance can only be positive or 0. Now, if there was a negative out front, we'd have to put it in standard form, and you'll see that as well. We'll put a negative out front. Now, this one's not in standard form, so let's put it in standard form before we do anything. So we're going to subtract 4 from both sides, and that's going to give us the absolute value of, once again, try to make your absolute value bars look like absolute value bars and not ones. And that's going to be equal to, and then that's going to be what? 9. So now we can apply a rule where we can have 5y minus 9 equals 9, or 5y minus 9 equals negative 9. Hold on one second. Alright, sorry about that. Family's home, so they're making a lot of noise. Alright, you may hear them later on in the background. So moving on, we have our two situations where we have 5y minus 9 equals 9, or 5y minus 9 equals negative 9. So I'm going to add 9 to both sides for this one, and that's going to give me 5y equals 18, and so that gives me y equals 18 over 5. Is that right? And then I'm going to add 9 to both sides here, and we're going to get 5y equals 0, and that's perfectly fine, because 0 divided by anything other than 0 is going to be 0. So I have two answers here. For y, I have y equals, I have 18 over 5, or 0, and the two possible solutions for that. And you can always check that. You can plug in 0 here, and you'll get 0 for y, -9, absolute value -9 is +9, plus 4 is 13, and 18 over -5, or 18 over 5 will work as well. Always check your answers when you have the time. Some problems require you to check your answers. We'll talk more about those later. All right. So general procedure for absolute value is put the equation to standard form by isolating the equation and absolute value on one side of the equation. Check whether there is a solution. There are two solutions if c is greater than 0, one solution if we're equal to 0, and no solutions if c is less than 0. In other words, negative distance. And this is assuming that our absolute value is on the left, the c is on the right, and we've put it in standard form. So if there is a solution, split the equations into two linear equations where we have ax plus b equals c, or ax plus b equals -c. Note these are the same equation if c equals 0. Solve the equations from step 3 using the procedure for solving linear equations. You'll just have to do 2 of them. So two absolute values. When we have two absolute values in the same equation, it's a little trickier to solve. The two expressions on the side inside the absolute values must either be equal, or one will be the negative of the other. So here they have 2 minus x equals the absolute value of x minus 1. Now in Hawks, you may see it written as the absolute value of 2 minus x minus the absolute value of x minus 1 equals 0. In other words, they put both the absolute values on the same side. You have the beginning additional step to move it to the other side, so be aware of that. And so this will give us two equations, which we will then go and solve. Now with this one, you'll notice something interesting happens here, is that if we, is it this one right here? This one right here, when we go to solve this, you'll see this in your homework, negative, so that's +1. You'll get negative x's on both sides. When you add x to both sides, the x's will cancel and you'll get 2 equals 1, which is never true. So this side is no solution. But this side right here, if we add an x to both sides, we're going to get 2 equals 2x minus 1. Move the 1 to the other side. And we'll get 3 equals 2x, or in this case, 3 over 2 equals x. So you could get one, just even though you have an absolute value and it's not set equal to 0, it's set equal to another absolute value, you get a situation where you get one number and the other one's no solution, and that may lead to an area where you're just like, okay, well if that's the case, you know, I'm just going to have one answer instead of two answers, even though I have two absolute values. So watch for that. You may see that in your homework, where one of them will be a no solution, the other one will have an answer. All right, next, so looking at this one here, we're going to have the following. We're just going to change the signs on the right-hand side. That's typically what we do. So we're going to get x minus 2. Since it's in standard form, we're going to get set equal to the positive version of this, or 3x minus 2 set equal to the negative version of this, which is negative 2x. And if you want to leave the negative on the outside so you don't forget to distribute, that's fine. So we get 3x minus 2 equals negative 2x plus 3. And so working with this one first over here, what we're going to do is we're going to subtract 2x from both sides. So we're going to get x minus 2 equals negative 3. I'm going to add 2 to both sides. So we're going to get x equals negative 1. And then over here, we're going to add 2 to x to both sides. And we're going to get 5x minus 2 equals 3. And so now I'm going to add 2 to both sides. So I'm going to get 5x equals 5. So that's x equals 1. Once again, I kind of expect students to be able to make this step here pretty intuitively. Now, notice this is negative 1 and this is 1, so my answer solutions are x is equal to negative 1 or 1. But It's not always the opposite sign. It just happened to turn out this way. This example just happened to have the same number with opposite signs. That won't always happen. I see some students, they get this example and they're like, oh, this is a negative version of that, so I'll just change the sign and be good. That's not what always happens. It's just sometimes you get problems that come out to nice answers for other reasons than that are readily apparent. All right, so now we're solving for a variable. To solve for an equation that has more than one variable for a specified variable, we follow the same procedure. We isolate the desired variable. So to solve d equals rt for r, what we do is we divide both sides by t to get r equals dt. Actually, when we did it, we divide both sides by t, and our t's cancel. We got d over t to equal r. Well, by the property of equality, we can just switch both sides for both of these, and we get the same number back out right here, or the same equation back out right here. So now this equation is solved for r in terms of d and t, instead of solved for d in terms of r and t. Distance equals rate times time is kind of what that's alluding to. So here it wants us to solve for r. So this one's not linear. We've seen linear before, but it's the volume equals 4 over 3 pi r cubed. So to solve this, first thing we're going to do is multiply both sides by 3. You can do this all in one step. I do that sometimes in my class. Is fine with it. Sometimes they do not. I'm going to do it in multiple steps. And now I'm going to divide both sides by 4 pi. Remember, pi is a constant. We just don't write it out. It's just some horrible decimal, 3.141 something or another. Probably wrong on that. Don't have my calculator out. Those cancel and I get, okay. Now at this point we've solved for r cubed. Now if we want to get rid of a cube power, remember our rules of power, if we had something like 5 squared, well, I could raise it to the 1/2 power, or if I want to get rid of that squared, I could take the square root of it. So here I'm going to take the cube root of both sides, and so that's going to give me the cube root of 3v over 4 pi equals just r. And that's our answer there. Here we want to solve for c, and this area equals 1/2 h times b plus c. So since we're solving for c, what we could do is distribute this out, but we just end up factoring it anyway to get the c by itself. So in order to do that, I'm going to take care of everything out front of this grouping symbol before I try to solve for c. So here I'm going to multiply both sides by 2 to get rid of that 1/2. So I have 2a equals h times b plus c. And once again, I can multiply through by h, but there's no point in doing that. I'm just going to divide both sides by h. And that's going to give me 2a over h equals b plus c. And so now I'm going to subtract b from both sides. That's an h. And so now that's going to give me, I'll write it over here, 2a over h minus b equals c. And that's our answer. And here, it doesn't, I know a lot of students like to get numbers back out. And sometimes if you have fancy calculators, although only use your scientific calculators, please, because those are the only ones you're allowed to use on a test. They have these larger calculators, and they'll put in letters, and they'll get actual numbers back out because the calculator has stored values for those letters. And so I see a lot of students, they plug something weird into their calculator, the actual letters, and the calculator gives them a value, a numerical value back out, because the calculator already has values stored for that. And so sometimes I get really weird answers back out in the hawks from students. Yes, I can see your answers to your homework when you put them in. So be careful of that. We're not solving for an actual number in that case. All right, so application problems, word problems. There are two formulas we frequently use for application problems. D equals RT, where D is the distance traveled, R is the rate or speed, and T is the time spent traveling. I equals PRT, where I is the interest earned when the initial amount, the principal P, is invested at an annual interest rate, R in decimal form given in time t years. All right. So here we have the following. We have 2 trucks leave a warehouse at the same time. One truck travels due west at an average speed of 60 miles per hour. My camera's gotten crooked again. 60 miles per hour, and the other travels at due east at an average speed of 46 miles per hour. After how many hours will the trucks be 265 miles apart? So once again, always draw a picture, if you can, of your scenario. So we got east and west, so they're directly opposing each other. So west is a left on a map, and so this is going to be 60 miles per hour. MPH. And the right hand side, average of 46 miles per hour, west, which is going to be to the right, or sorry, east to the right, and that's MPH. And then how long will it take them to get 265 miles apart? So here we're basically adding the rates together for some time t. This is going to be rate 1, r sub 1. This is going to be rate r sub 2. And so I want to know when the distance d equals rt. This pen's running out. Let me try this one. So what does that mean? I want the distance equals the first rate plus the second rate times time. So in other words, I want to know when 265 is equal to my first rate, 60, plus my second rate, 46, times t. T is what we need. Now, in the homework, what they can have you do is solve for t and say that you want d over r equals t first, and they'll have you, especially if you're going through the practice, they'll want you to put it in this form first before you solve it. But since you're plugging in real numbers anyway, I find it's easier just to plug it into the function you have instead of trying to solve it, because some students can make a mistake at that point. And so what we're going to get is 265 equals 106. Is that what I want? Yep. And that's t. Don't need the parentheses. So we go over here to our calculator. And once again, it's pink because it's my wife's calculator. I wanted purple. They didn't have any purple. So that's going to be 2.5. So 2.5 is when I divide both sides by 106 equals time. And sometimes they'll say round off to the nearest, if it's in hours, decimal hours. Rarely will they ask you for hours and minutes. If this is hours and minutes, then this would be 2 hours, 30 minutes. I don't think I've ever seen them where they actually want it in hours, minutes. Usually fractional hours or decimal hours is fine. If they want it in fractional hours, you could just say it's 5 over 2 hours as well. That'll work as well. It should take this or this answer. Usually it doesn't ask it broken up in hours and minutes. All right, next, Julie invested $1,200 in a risky high-tech stock on January the 1st. On July the 1st, her stock is worth $1,260. She knows that her investment is very volatile and does not earn interest at a constant rate, but she wants to determine her average annual rate of return at this point in the year. So what is the effective annual rate of return that she's earned so far? So we're going to have interest equals principal times rate times time. And so we know the time, it's going to be in years. So years, and since it's from January, which is the first of the year, all the way to July, which is the middle of the year, 7. So it's going to be 1/2 years. And then so that's going to be our time. Our principal that we're investing is $1,200. And our interest is not $1,260. It's actually $1,260 minus $1,200, give you $60 in our interest. So now we need to go and find the rate. Once again, they may have you solve for the rate by saying, over here, I'll just write it over here, interest equals principal divided by time equals rate. They may have that, have you solve for that. Here, if you're just plugging in real numbers, it's easier just to plug in the numbers and say 60 equals 1200, and then times your rate, which is unknown, 1/2 is your time. So looking at this, divide this in half, we're going to get 60 equals 600 R, and so that's going to divide both sides by 600. And so in doing so, we're going to get one of our zeros, and that's canceled. So I think we should get 0.1 equals rate. Our rate should be 10%. Oops. Remember, rate is given in percent often, but we need to write it in decimal in our equation. And so let me make sure that's right. I could have done something silly. Wouldn't be the first time. Yep, 0.1 or 10%. That's our rate. So if they ask for it, what's the effective rate she has earned so far, usually they'll ask for it in percent, 10% in this case. But in our equation, it's in decimal form. Now, in many things in life, they actually have a math component. Sometimes you don't recognize it, and you may be able to hear that was my small child. Sorry. You may be able to ask to complete a math exam, especially if you're dealing with money. And one of the ones that will always show up, just to make sure if you know what you're talking about with algebra, is a question like this. It says, Mary buys last year's best-selling novel in hardcover for $22.10. This is with a 15% discount from the original price. What was the original price of the novel? 90% of people that take these tests with this answer or this question, assuming they know what they're talking about in the first place, will take 15% of the price of the number they're given, and they'll subtract that from that same number and call it a day. That's not what's happening here. Here, when we're dealing with an equation like this, we have x is the original price. And we're going to subtract off the discount, which is 15% or 0.15, and that's the discount. Now, that's 15% of what? The original price, X. And that's going to equal sale price, which we said was $22.10. So I'm going to have X, and remember there's an understood and 1 in front of that X coefficient, minus 0.15 X, so 1, equals $22.10. So that's going to be 1 minus 0.15 x equals 22.10, and so that's going to be 0.85 x equals 22.10, or 85% of the original price was 22.10. So now we're going to divide both sides by 0.85. Since I'm dividing by something less than 1, this should make that number larger. If you get a smaller number, you've made a mistake. And so that would be 22.10 divided by, whoops, I was almost about to do it, 26 even. And a lot of times these answers in Hawks will come out to nice even answers, but that's not always guaranteed. If you don't get a nice answer back out for the original price, in this case $26, check your math. You may have made a mistake. You could get decimals back out or fractional cents, but usually they give whole number prices back out. All right. So that's it for today's lesson. Y'all have a great one.